Welcome to the fifth lecture in Module 2, and in this lecture we'll talk about version control. Even if you're a single developer, the ability to use version control is important, and as you start to work in larger teams it becomes even more important. Now Rails has some version control capabilities that are commonly used by many people, and I'm going to present them to you in the next lecture. But in this lecture we first need to understand the basics of how version control works. Before we do that, let's listen to a little bit of music. Well, they performed a very famous song called Midnight Train to Georgia. Well, what about that song? It's considered the signature song of Gladys Knight and the Pips, as well as one of the greatest R&B songs of all times. In addition, Rolling Stone magazine considers this one of the top 500 songs of all time. Now, why am I talking about this? Well, the first version of this song was called Midnight Plane to Houston, and it was about somebody who was going from Nashville to Houston, not LA to Georgia. So this song evolved over time, and the same thing happens with any creative work. It evolves over time. We'll see the same thing with software. It's very important for you to be able to track the various versions of software as it evolves over time. Let's start by defining version control, and sometimes you hear this referred to as revision control or source code control. It's the practice of tracking and providing control over the changes that's made to source code. And you want to be able to do this in case you need to back up to a previous version, or if you want to allow multiple people to work on a project at the same time. The need for managing software versions has existed as long as there's been software. And it's commonly used by a development team in order to track the various pieces of the code, artifacts, documentation that the different members of the team are working on, and it allows them to work simultaneously and save their work as well. Let's look at the case of a single developer. With a single developer, you've got a version control database here, and on that version control database I show a couple of versions of this software on your local computer. This could be your file system, or it could be a version control system database as well. Now what happens if you want to check out file A, let's say, from version 2 and edit it and change it, you make those changes and you stick it back into the file system. And it's very easy for you to go and pull some other version out of that version database. And so even as a single user, this is a common thing for folks to do, is to save various versions of the software they're working on in case they need to back up if they make a mistake, or many cases folks will, if they're creating a new feature, they'll stick that into a different version until they get all of the various bugs associated with that feature worked out, and then they'll move on to the next version. Now, how about if you're part of a development team? If you're part of a development team, it's very common to have a centralized version control server. This allows multiple developers to work at the same time. So here I show developer 1 has checked out file A from the second version of this project. Developer 2 checked out file B. Generally what happens in centralized version control systems is, since developer 1 has checked out file A, developer B is prevented from working on it. That's a common framework that people use with centralized version control systems. So developer 1, developer 2 can both work independently on different files and check them back into the version control system at some point in time. Here's what that looks like. With centralized version control systems, you only need to store the differences between files from one version to the next. And so here I'm showing version 1 consists of 3 files. Version 2, only file C was changed, and so there's the first change, and only that change is saved to the database, not the entire file. And in version 3, the other 2 files are changed, and so on and so forth until you get to the last version here that I show. Let's contrast this now to distributed version control. As software has become more distributed, and Linux, by the way, the Linux kernel was developed in a very distributed manner. A prime example of the importance of distributed version control is the Linux system. It was team-based, people working all around the world making contributions, and they had to be able to check out pieces of that, work on it simultaneously, and then submit it back up in order to get this operating system working. In distributed version control, there's no centralized repository. The team members don't check out files like we just saw in the centralized system. They check out the entire repository. So the repository is not locked like I showed in the centralized case, and other team members can download the current version, work on it. This presents a problem, though, because what happens when you want to put these things back together again, when you want to check the project back in? Well, you've got to mark those differences and try and merge them. And so that's what tends to happen with distributed version control systems. You have these snapshots that you must merge together at a later point in time. And typically, it's the owner of the repository that's responsible for doing that merging. And the merging itself is usually accomplished with the help of some tools, merge tools that help you with this process. Let's take a look at what happens with distributed version control systems. As I mentioned, the entire repository is stored every time. And so here we see in the second version, file C was changed, and that change is noted in the entire set of files is stored with version 2, version 3, and so on. And this is the same set of changes I showed you before, except each time the entire repository is saved. Again, snapshots are saved of the software, and so you can go back and forth the various versions of those snapshots. Let's look at how this works within a distributed development environment. So here's our server, and it's very common in a distributed environment to still have a centralized server that folks can go to in order to grab the code and use it. You don't have to. It's possible to do this without a centralized server, but the way we'll use it in this class is with a centralized server. And here we have developer 1 checks out the repository and is editing file A. At the same time, developer 2 is also editing file A. Another interesting fact is with distributed version control systems, they can collaborate as well directly and share their code changes. Again, the important step is as these changes are placed back into the server, there's got to be some merging step in order to reconcile any differences between the changes made in the two files. So typically it's the responsibility of whoever owns that server where the repository is stored and all the developers are pulling from of merging in the changes. And again, typically there are merge tools that help you do that. So this completes the 5th lecture in Module 2.